Okay, I think we will get started, and I'll just have to try and let people in as they join. So hello and welcome to our webinar on the UK Hydrographic Office Marine Innovation Challenges. We're going to discuss how BMT won the first challenge, unlocking autonomous navigation, and then we're going to discuss how these solutions can be developed using the Smart Sound in Plymouth as an example. So thank you everyone for joining, and thank you especially to all of our speakers today. So before we do get started, although I'm pretty sure everyone's very used to Zoom meetings now, but if everyone can keep their microphones and their cameras off throughout the presentation, just to reduce the background noise and the disturbances. And as the presenters are speaking, if you'd like to submit your questions into the chat function, which should be at the bottom of your screen, then after each presentation and at the end of the webinar, there's going to be opportunities to ask those questions. So make sure you submit them as we go along. And then just a note really to say that I'm recording this, so the recording and the slides will be available afterwards. So just to give you a brief overview of what we're going to discuss today, we're going to start with a brief introduction to SMI. Then I'm going to hand over to Mark Casey from UKHO to discuss the innovation challenges. Then he'll hand over to Phil Thompson from BNT to discuss the winning solution for the Unlocking Autonomous Navigation Challenge. And then finally, we'll hear from Rob Watson about the Smart Sound Plymouth. And then, like I said, at the end, there'll be a final opportunity to ask any extra questions that you've thought of as we've gone through. So firstly, I'd just like to give you a brief introduction to myself and to SMI. My name is Emma Johnson and I'm the new Business Development Director at SMI with a focus on marine science and technology and marine autonomous systems. So the Society of Maritime Industries is the voice of the UK's maritime engineering, technology and business sectors. We promote and support companies which design, build, refit and modernise ships and supply equipment and services for all types of commercial and naval ships, ports and terminal infrastructure, digital technology, maritime defence and security, marine science and technology, marine autonomous systems, and marine renewable energy. So as a trade body, SMI provides innovation and insight and engages with the government to advise on the maritime policy in the UK. Our main purpose is to profile and promote the UK maritime and marine science industries while collaborating with other trade organisations. We enable our members to network with other members as well as with external groups in forums such as this one, or normally in person when we're allowed to. So in order to achieve our aims and missions, our activities are quite wide-ranging. We hold UK seminars and conferences like this one. We represent the UK at international exhibitions through our UK pavilions. And we continuously work with government and other bodies such as Maritime UK to lobby on behalf of our members. So we've created 6 special interest groups at SMI with relevance to our members. Those are the commercial maritime operations, the marine science and technology and marine autonomous systems groups, which are the 2 that I focus on. The Naval and Maritime Defence Group, the Digital Technology Group and the Ports and Terminals Group. And these groups further enable networking between our members, large and small. So thank you very much for listening to a very brief overview of SMI. If anyone has any questions or you're interested in joining, let me know. You probably all have my email address, but if not, it's on the screen now. We'll be sharing these slides afterwards, so you will have access to that. I'm now going to hand over to Mark Casey from UKHO to discuss the innovation challenges. Mark, over to you. I'll stop sharing and allow you to share yours.
Thank you, Emma. Okay, hopefully you can all see my slides.
That's perfect, yeah.
Brilliant, thank you. Well, good morning, everyone. As Emma said, I'm Mark Casey. I head up the Research, Design and Innovation team at the UKHO. Next sort of 15 minutes or so, I'm just going to talk to you a little bit about the UKHO as an organisation and who we are and what we do. Then talk a little bit about our Marine Innovation Programme and why we're doing that. talk a little bit about why we did an event on autonomous vessel navigation, and then share some details about the autonomous vessel navigation event, which, as you all know, was won by BMT. Just to set the scene, we have a rich history in doing what we do, and this year will be our 226th year of operating as a hydrographic office. Just to highlight some kind of highlights over the years, we were founded in 1795 by a royal warrant from King George III, so we've been around a long time. The first nautical chart was created in 1800, and the first one was sold to the public for the first time in 1808. In 1830, sailing directions, tide tables, and notice to mariners were published. And by 1855, we had over 2,000 charts published covering the globe. Printing moved to Taunton in 1939 because of the war. There was less of a bomb threat, and we were nearer to the Royal Navy base at Plymouth. Throughout the 60s, there was a program of metrification of the charts, and the rest of the UKHO moved from Cricklewood in London to Taunton in 1968, and that's where we are now headquartered. Over the 90s, new products and services were launched, so the Admiralty Leisure Chart Service, Admiralty Raster Chart Service were all produced then, and the UKHO became a trading fund in 1996. The first official ENC was produced in 1997 after the IHO agreed the ENC specification, and the Admiralty Vector Chart Service was launched in 2008. And the picture on the right-hand side there is our new building. So we're in our new state-of-the-art building. Well, I say we are in it. Obviously, we're all home working at the minute, but that is the new state-of-the-art building, and it can reflect where we're going as a modern hydrographic office and wanting to be a world-leading marine geospatial information agency. So as mentioned, we've operated as a trading fund of the Ministry of Defence since 1996, and all our activities are funded from the sale of hydrographic products and services. As an executive agency of the MOD, we're responsible for providing operational support to the Royal Navy and other defence customers, supporting the Maritime Coast Guard Agency's obligations to the SOLAS Treaty, ensuring hydrographic data relating to UK coastal waters is accurate and up to date, and providing expert advice on hydrography and related marine geospatial information to the government and reporting to UK government worldwide. We have a global series of products and services, and further to this, we're also the primary charting authority for a number of states who don't have their own hydrographic capabilities, which amounts to around 71 coastal states around the globe. So we assist these states to ensure that hydrographic and nautical information is made available on a worldwide scale as timely, reliably, unambiguously as possible in accordance with SOLAS Chapter 5, Regulation 9. We receive data from a wide range of global sources. This can range from large, fully controlled multi-beam surveys to simple crowdsourced hydrographic notes, which mariners send into us when they see a discrepancy on a product in relation to the real world. We receive survey data from Royal Navy ships, the Civil Hydrographic Programme, which is actually administered by the MCA, and third-party organisations such as energy companies or even academic institutions. As well as receiving that data, we get data from foreign government hydrographic officers. So we have bilateral agreements with all the other HOs around the world to exchange data. We have arrangements with local harbour and port authorities, and we have over 100 port agreements around the UK alone. And as I said, we receive independent data coming from mariners via our H-Note application. So our products and services are a comprehensive SOLAS compliant charts and publications and digital services. They are actually found on 90% of the world's ships trading internationally, and have been relied upon by mariners for over 200 years. And I'm sure there's people on this webinar now who are very familiar with the Admiralty products and services. So this slide's just a quick canter through those products, which some of you may be familiar with. So on the left-hand side, we have our standard nautical charts or paper charts. There's over 3,000 of these in the current series. We produce over 70 nautical publications, which are supplementary data to support the charts. As mentioned earlier, we've got our Admiralty Raster Chart Service, or ARCS, which is our first foray into digital products. We then have the Admiralty Vector Chart Service, or AVCS, which is the world's leading ENC service, which offers the most comprehensive official coverage available. Then we have our Admiralty Digital Publications and the e-nautical publications, which is a digital version of the paper books. But the point I want to kind of really labour here is that Admiralty is the brand. That's what we sell, the Admiralty brand, but we are the UK Hydrographic Office, so it's important to make that distinction. So yeah, in summary, we make these navigation products and services. We sell them to these customers, hopefully to stop these kind of catastrophic navigation incidents happen that we see here on the right hand side. So it's a very flippant side, but it's a very serious slide. So what I've just really talked about is what we consider our primary task, our main function, what we kind of exist for. However, we recognise that a lot of the data we hold that's used to produce those navigation products and services for mariners has a lot of value in the wider blue economy, in sectors that are probably new to the UKHO. And I've got a short video I'll play just to give you a sense of where we're heading as an office. And I'm going to apologise right now, there is no sound due to the way I've joined this meeting through Zoom. But really all you're missing is some fancy kind of marketing music. The words on the screen will paint the picture. So it will be a bit quiet for a minute or two, but please watch the video and get a sense of where we're moving. So in response to that new adventure that was talked about in the video there, we've launched the Admiralty Marine Innovation Programme. This programme is looking to expose UKHO data in order to stimulate innovation in the wider blue economy, which is probably outside of our traditional navigation markets. We recognise that the UKHO is not an expert in many of the sectors in the wider blue economy, but we have data that may be of value to experts, disciplines or industry players within those different sectors. For example, the oil and gas industry or offshore renewable industries. And therefore, through a programme of events, we want to attract innovators and entrepreneurs to use our data to come up with new and exciting products and services that can solve problems in the blue economy. So to summarise what the Marine Innovation Programme is about, the following vision statement covers what we're trying to do. So the main purpose of the UKHO's external facing innovation programme and events is for the UKHO to work with and help industry partners create sustainable go-to-market products in the wider blue economy in order to derive new value from marine geospatial data. So this is our first year. This is the first attempt at doing this, really, and it's kind of a bit of a pilot for us to see if this is an enduring capability that we want to take forward. So in running this, we've got 3 additional aims this year, really. One is just to test the sustainability of the external innovation capability, because we're investing quite a significant amount into these events. So we want to understand if this is something that we can sustain. We want to learn new skills in how we facilitate innovation with external partners. Which is really, really important and something that's, again, brand new to us. But the other thing I think is, which is probably as important as all that, is to show that there is demand for the UKHO data, and we can build a community of partners who want to innovate in the blue economy. So the approach, largely down to COVID-19, was to run online and virtual events to expose our data to innovators, enable them to take the most promising ideas through our innovation process to test their concept in the market. And we've used a mix of online challenges and design sprint events to do that. So view these as kind of friendly Dragon's Den style events, though Phil in a minute may share, how friendly that actually was. But that's the kind of way we've conducted these events. So we've run 3 events so far this financial year with different themes and style of events. Our first event was based on autonomous vessel navigation, and I'll talk a little bit more about that shortly. But as our first event, we decided to use a week-long design sprint approach, which allowed us to get some really good engagement with all of the participants. For those of you who haven't done or used the design sprint framework, it's a really fast-paced, dynamic, week-long event designed around rapid prototyping of ideas. Essentially, you start on the Monday with a vague idea or notion of something, and then build upon that idea throughout the week. And then on the Friday, the idea is you have crude prototypes to test with your target market. The reason it's quick and you build crude prototypes to test is that you can learn quickly without significant effort whether an idea is market fit or not prior to further investment or development decisions being taken. But I'll come back onto that autonomous vessel navigation event in a second. Just to touch base on some of the other sort of events we ran, we also ran an event looking at how UKHO data could help in the maritime risk and insurance sectors. In this one, we ran an online challenge, and we had 25 registrations from 6 countries, and we appointed a company called Geolec from Bristol as the winners in December. We also ran another design sprint focusing on the offshore renewable energy sector. We had 16 applicants in total, predominantly UK based, which I think illustrates how UK is one of the leading players in the offshore renewable energy sector, particularly around wind energy. And we've just announced that Marico Marine were the winners of that challenge. But back to the autonomous vessel navigation challenge. Why did we do that for our first event? Well, the emergence of autonomous vessels is a disruption to the shipping industry and could be a threat to the UKHO business model due to the fact that there's potentially no one on board actually reading charts and publications anymore. But given the autonomous vessel industry isn't that significant at the minute, how big a deal is this? Well, perhaps the industry is a lot bigger and more significant than we realise. There's currently over 1,000 autonomous vessels in use today around the globe. And they're fairly small craft today, used in like surveying, in the oil and gas industries, marine science, offshore renewables, used for mine countermeasures, anti-submarine warfare. But as I said, they're small, they're outside the regulatory landscape in terms of using official SOLAS navigation products and services as supplied by an official hydrographic office under SOLAS Chapter 5. But they are getting bigger. Lots of people have seen Yarra Birkeland and all the press around that. And this just illustrates the intended direction of travel for autonomous shipping. So the exam question is, how do we navigate a large SOLAS autonomous vessel in the future? And I just want to highlight that the challenge space here is a fully autonomous surface vessel, not remotely operated, but something that fits into the 4th degree of autonomy according to the IMO definitions that are shown on the slide here. So I guess what's the big deal from a UKHO perspective? I know there's people on the call that probably heard me talk about this before, but the main issue really centres a lack of regulation, rules or standards relating to navigation data in an autonomous vessel. Whilst autonomous vessels will become aware of their surroundings, use sense and avoid technologies, these vessels still need navigation data to get from A to B or avoid key areas or operate differently when entering a specific area such as a port. To suggest that autonomous vessels will be able to use current charts is inappropriate for the following reasons. ENCs are still fundamentally designed to be viewed and interpreted by a human being, and they're used to inform the mariner and help them make decisions based on the chart information, their knowledge and extensive training, what they see out the window, even the pitch and roll of the vessel. ENCs are made using traditional cartographic practices, which can be subjective in nature and therefore only represent the ground truth. Indeed, the art of cartography is actually in filtering the information so as not to overwhelm the mariner. But as a result, we often see data inconsistencies, which mariners can identify and resolve. Humans are very, very good at that. And if you look at the image on the right-hand side here, we can see two ENCs that cover the same area, albeit at different scales, but you can see that kind of discontinuation or different representation of the data. Again, human beings can figure out what's going on and use that product safely. ENCs also suffer from horizontal inconsistencies, specifically edge matching issues when transitioning from one ENC to another. And we often see data discontinuation, again, which humans can identify and resolve. That said, a gridding approach will solve most of these edge matching issues, but you still have this scale issue going on, which will be a challenge for autonomous vessels. But a major area of concern is that ENCs don't contain wider contextual information which mariners need to make safe decisions, such as the information contained in the sailing directions or radio signals, or even that which is sometimes displayed as notes on the chart edge. This information is crucial to mariners, as these notes often describe the kind of rules of the road, if you like, and describe restrictions or constraints that mariners must follow. The information can't be encoded in ENC as the standard is 20 years old and won't be developed further. Therefore, new navigation data servers that are rich in data and detail and can be machine readable and interpretable are needed. So just got a couple of slides just to illustrate that then, so that this image, I think, illustrates the filtering kind of problem quite well. What we have here is the underlying survey data, which is shown in blue, and note how highly detailed it is. Overlaid, we have the contours which cartographers derive from the survey data and put on charts. Now, I'm not saying that the contours are unsafe, far from it, but it is an uncluttered, unfiltered, filtered view of the seabed. And due to the 10-meter intervals often employed on charts, it's a very coarse view of the seabed. Now, humans would struggle to interpret the survey data or perform that basic analysis when navigating, but a machine is capable of consuming tens of thousands more times data than a human can. So maybe there's no need to filter data for autonomous vessels. Here's an example of a restriction when entering Southampton. Note the channel has no geographical polygons illustrating the areas described in the text there. And equally, therefore, there's no attribution to allow a system to interrogate and work out how it should operate when entering the channel. So as mentioned, S57 is not extensible. So how do we model these features and this data to allow an autonomous vessel to interrogate the features that it will encounter on its journey and then behave accordingly? And this is just another example. This is an extraction of one of our sailing directions books describing speed limits when approaching or entering Plymouth. Note the verbose use of language and a lack of specific geographical descriptors. How would an autonomous system know where Fisher's Nose is, for example? So this really sets out the problem space with existing navigation standards and why we wanted to have a challenge in our innovation program to work with innovators to look at some possible solutions. So back to the event itself. So we exposed numerous data sets to the participants, ranging from high resolution gridded bathymetry to tidal height and tidal stream data via an API. And the sample data sets was based on the Plymouth Smart Sound area. Through our outreach and social media, the Autonomous Vessel Navigation Challenge generated 22 applications from 9 countries. We down selected to 5 companies to take forward to the design sprint event. And we had a good mix here of large industry primes and 2 startup companies. And the idea, as I say, was to work with each of these organizations to develop their ideas in the design sprint. A winner was chosen the following week, and their idea is now being taken forward with support from the UKHO. So as you all know, the winner was BMT, and I'm sure Phil will elaborate a lot more on what their winning submission looked like and how they're going to use their ideas in the autonomous vessel navigation space. But before I hand over to Phil, I'm happy to take any questions.
Brilliant. Thanks very much, Mark. That was really interesting. I've got one question that's come in terms of running the events remotely. So how did you find running these remotely? And if you were going to run them again in the future, would you do it remotely or would you prefer to do it?
Yeah, it's a really good question. So when we sort of set out on this innovation program, if you like, and we were thinking about it, COVID hadn't hit. So the intent was to run these events in a physical location. So maybe hire out a venue and, you know, get everybody on site. And then when COVID hit, we kind of did a lot of beard stroking and thought, well, how is this going to work? And I must admit, we were sort of slightly concerned that it could fail from the word go. But actually, with the use of technology like Teams and Zoom, we found that actually one of the kind of benefits that we weren't really considering was that we attracted people from around the globe. And obviously it was a low barrier for them because they didn't have to jump on a plane and incur expensive hotels and the rest. So that worked really well. And as I said, the use of the technology meant we could collaborate quite nicely with the participants. That said, it is a little bit awkward, particularly the first couple of sessions when you're just trying to get to know people, and it does feel a little bit awkward. Whereas if you were physically in a room, you could, you know, have breakouts and go for coffee and just kind of get to know people a bit more organically. I think going forward, I would still like to do a physical event to do a kind of compare and contrast to see what works best. I think one of the challenges we have experienced with the virtual is that, you know, people can get distracted by work. So whilst they're on a Teams meeting, an email may come in from their boss saying, you know, we need to do something here, and therefore they can get distracted. Whereas, of course, if they're in a building, you know, they're away from the distractions of work. So the jury's out on whether virtual versus physical is the way to go going forward. But I was pleasantly surprised how well it went, given we had to do it in a virtual environment.
Brilliant. Yeah, I think that's a general feeling, to be honest. It's virtual is good, but it's not necessarily exactly the same as doing it in person. So I'm not sure if anyone else has any other questions. If anyone wants to unmute and ask a question, I'm happy with that, or send them in the chat. I guess, because you said about running this as this was the first round of challenges, to sort of see if it was sustainable and see if it could be useful going forward. And do you feel that it was? Do you think it's something that you will be running again going forwards?
Yeah, we definitely are. I think we're really pleased with the results, and just the fact that we managed to attract some great organisations and from around the globe. I think has shown that there's appetite. I think what was really interesting is that, you know, people know us as the provider of navigation products and services. And we were kind of slightly concerned that could we attract people from the wider blue economy to come and work with us, because we may not be known, but actually through our social media and outreach, we have managed to attract people. So we have got an event coming up soon, which will be run out of our Singapore office, actually, around looking at coastal inundation. And then there'll be a number of different events next year, which we'll be looking to do. So it's, you know, basically keep your eyes out for a steady drumbeat of events coming from the UKHO.
Brilliant, very exciting. I'm looking forward to hearing about them. Thank you very much, Mark. If anyone thinks of any questions going forward, that's fine. Just pop them in the chat and we can come back to Mark at the end and ask them if you want to. So now I'm going to hand over to Phil Thompson from BMT to discuss their winning solution. Phil, if you'd like to share your screen. Yep, brilliant. I can see that. Perfect.
Oh, good.
Over to you.
Good morning, everybody, and thanks, Mark, for sort of providing the background to the Innovation Challenge, which I'll clearly not repeat. But I'm going to talk today about how BMT approached this, and just working through. Just see, excuse me. Trying to share the screen. Hopefully that will work now.
Yeah, that's there, yeah.
There we go. Okay.
Yep.
Well, thanks again to Mark for providing the background to this. Where BMT came from this is we felt we had two sort of aspects of innovation that we wanted to bring to bear. One was actually in sort of combining or fusing two very separate but synergist products. One is called Rembrandt, which is an established ship simulator package that has been in use and used by many of the sort of maritime stakeholders across the world for 30 years on board ships and ashore. And In Australia, the BMT team, which has developed a coastal hydraulics simulator called Tuflo, and you can read all about that on tuflo.com. Very powerful, two different but very powerful individual simulators that we fused together. And that was fused and designed to allow multiple very high granularity UKHO datasets to be fed in to undertake a synthetic modeling of a vessel, autonomous vessel navigating in Plymouth. We also used a number of other data sets as well, above and beyond the UKHO data sets. And sort of the image on the right-hand side covers LiDAR, very high granular bathymetry, which was, I'll get onto the S100 side of things, but that was S102 bathymetry, which is basically very granular bathymetry models. It also provides AS live data, where needed, EO data, tidal APIs from the UKHO, full seabed composition models for the system to understand where, if it actually needed to, where it might be safe to ground, weather data, ship routing information, maritime limits, and hydrodynamic ship models through the Rembrandt simulator. We selected a 140-meter port autonomous ferry and utilizing Rembrandt's autonomous autopilot function. Rembrandt handles manned ships and also autonomous vessels as well, and it's been adopted by sort of leading players in the industry in both areas. And we chose a flood tide, particularly challenging sort of environmental condition coming into Plymouth. It's really just to stress test the data fusion and the decision making. We believe the solution that we've developed, and that I'll sort of go into some detail with you in the presentation, it really does address the most likely real world scenario, which is a gradual transition from what are shared water spaces now with manned and small unmanned traffic interactions through to eventually, 15 years, 20, 25 years, through what hopefully will be a full autonomy world in the long term. But it's also the solution that BMT came up with is future-proof for what we would call S100 data applications as and when they become available. And this graphic here, which hopefully you can all read, is just a description of the new International Hydrographic Office S100 standard. Mark mentioned briefly S57 ENCs and what the IHO are doing, and I know the UKHO are looking actively into extending their product base around more granular and more dynamic data sets, which are required within S100. It's essentially a data standard, a framework document, which is intended for the development of digital products and services for hydrographic, maritime, and GIS communities. And it's not mandatory, but it's where I think things are clearly moving in the medium to long term, and addressing some of the limitations of S57 for autonomous navigation. The idea of actually eventually deploying fully dynamic data sets in terms of, for example, dynamic water heights, ultra high granular bathymetry, highly dynamic and highly granular surface current data, all of which would be required for safe autonomous navigation. And all of those have been addressed in the current BMT solution that we came up with. So basically what we've done is we've employed not just bathymetric data from the UKHO, which is S102 level equivalent, but we've also used existing information from the API UKHO tidal apps and used our coastal hydraulic simulators to benchmark and calibrate those models to create S111, which you can see in the highlighted there, very granular surface current data in terms of heights, directions, and velocities, so that we're adding value to the UKHO data to create S111 equivalent data sets, which we then use, and it's fed into the autonomous navigation model in real time, and of course the dynamic water heights. Because we're doing that, it's also opening opportunities to get, if you like, next generation undercarriage clearance, because with ultra high granularity bathymetry and very granular in terms of temporal and spatial granularity in terms of dynamic water height data, it opens up the door for much more granular under-keel clearance tools as well. And we'll explore that, and I'll provide you with some examples of what we did there in there. So that's basically the S100 world, which is it's not futuristic, it's clearly on the horizon. And it's clearly where the IHO and the UKHO and other national hydrographers intend to move. But what we've tried to do is future-proof it for S100 and what BMT did. So getting back to the UKHO data, this just summarizes the data we did use from the UKHO in this. I've mentioned about bathymetry. You can see on the two there comparison between S57 bathymetry data, and next to it on the right-hand side, the S102 equivalent. Now, it's not immediately apparent. If you look close enough, you can see quite a lot more detail shown in S102, which our models used. Plymouth is not that interesting in terms of bathymetry. There are certainly more areas of the world we could have chosen, which the contrast would become very stark indeed. But that shows you there. We've used LiDAR data, intertidal data as well. We used 12 UKHO tidal height discrete data points and 30 tidal stream data points, which, as I mentioned, were then used to calibrate a high-res 10-meter, 50-minute grid hydraulic model to generate the S111 equivalent dynamic tidal height and surface current velocities and directions. We took UKHO seabed composition to so the system could actually assess where, if needed to, it would be safe and not safe to ground. We required intertidal data as well, so that our coastal model also took into account terrain data for rainflow into the tributaries, which would then impact something like surface current and tidal heights as well. Notes to mariners, e-notes to mariners were included, as were maritime limits, ships routing data. We used AIS, and that's something which Rembrandt is already AIS enabled in any event. So that gives you a view of the quite extensive amount of UKHO data that was used in this. Just brief, Rembrandt stands for Real-Time Maneuvering, Berthing and Training. It's a 3D time domain navigation seakeeping simulation software application. It's used on board most of the world's cruise ships, for example, LNG vessels, but it's predominantly used in ports and by pilots and in the offices of ship management companies and most of the key statutory marine accident investigation bodies around the world, including the MEIB and the US NTSB as well. So it's been fully stress tested and is used day in and day out throughout the world on a wide range of things, from port planning, port approach, autonomous navigation, STS operations for LNG in West Africa, the whole thing. And so it also allows, it's very scalable. We have full-scale mission bridge simulators, DNV Class A approved, through to laptop versions as well. So it's very scalable. And the software now, of course, is able to utilize what I've termed S100 data sets where available. Fully AIS enabled, so you can have live traffic interactions as well, and full playbacks. We've developed tools in there through our work with the MEIB and the US NTSB, where if there's an accident, you can replay it and stop, pause, and then take over to look at what should have happened, which is very important, actually, and quite interesting as I get onto for autonomous navigation, as we sort of stress test sort of COLREG compliant decision-making on autonomous vessels. These are just some of the applications here from, floating oil and gas applications where you're moving huge structures down very narrow channels and you have 8 independent tugs required to move expensive assets without knocking them against the bank or the seabed, through to the world's largest cruise ships, container ships, STS operations, port planning, through to full bridge manned training systems. So that gives you an overview of where Rembrandt is, and it's also used by a number of leading autonomous vessel operators, to support them in their operations, and for example, accelerated training of their own AI decision models by generating synthetic imagery and to train AI on recognition and what's out there, rather than sort of putting vessels out there to train over a longer time. The BMT TwoFlow simulator, we have over 700 companies worldwide, and at this point I want to pay sort of tribute to the teams involved in this. The teams actually were involved in the winning solution were from the UK, BMT's UK team in simulation training, and our excellent team in Australia who run the TwoFlow modeling. And it was really a combined 24-hour effort around the clock for that week on the design sprint, where our guys in Australia were developing the TwoFlow modeling and feeding that back us overnight, and we were generating the Rembrandt modeling using the TwoFlow data streaming coming in. So it really was a very good team effort from the UK and the Australian teams within BMT. But TwoFlow, you'll see, if you want more information, just twoflow.com. It is a leading 2D and 3D computer simulation software package for flooding, coastal hydraulics, sediment transport, water quality assessments. There's also full coupling to SWAN spectral wave models. And in particular here, we use TwoFlow to take UKHO discrete tidal height and tidal stream data to generate very high granular gridded data for down to, I think it was 10 meters, 10 meter by 10 meter gridded surface current data and water height data. So overview of Plymouth TwoFlow modeling. First of all, the model itself was fed into the Rembrandt software. We predicted high resolution water levels, depths and currents for input to Rembrandt. And to give you an idea of how quick we can do these now, because of the flexible meshing within TwoFlow and the GPU solvers, it only took BMT, I think, between 24 and 36 hours to build the particular Plymouth full hydraulic model, and then to get those files ready for import into the Rembrandt simulator. And we developed a gridded model down to 10 meter spatial granularity and between 5 and 15 minutes of temporal granularity as well. Again, all done in less than 2 days. Just shows you here the wider gridded hydraulic model that was developed around Plymouth, linking in UKHO bathymetry and CMAP data, the August astronomical tide boundaries. The mesh there was 10 meters through to 2 kilometer horizontal resolution. Just zooming in, you can see the gridded bathymetry used here. And as we go further and further into the area of interest, and down into the Rembrandt study area where we were carrying out the autonomous vessel navigation. So the idea there that the TwoFlow model provided down to the sort of granularity of the ship navigation route, you can see here the full dynamic spatial currents and water height data for the area that Rembrandt needed to be fed in real time. In terms of calibration, of course, we got excellent calibration with the UKHO data points on observed versus simulated for both tidal heights, tidal velocities. And I just want to emphasize, in terms of the calibration was really excellent, both in terms of phase and amplitude, and also tidal direction. So the idea there is we could take any port and if we've got some discrete data for ground truthing, we can develop a model, full hydraulic model, in that sort of time step of a day to 2 days, and calibrate it with any tidal metering that's in place as well. So that was what we did for Plymouth. The trial itself, you'll see here had the ferry model. We chose a 150 meter ferry model. In discussions with some of the Plymouth pilots about what sort of ships would they like to see coming in the longer term. As this is a synthetic model that BMT has developed, we could almost choose anything, but we wanted to make it realistic and obviously applicable to Plymouth in terms of the vessels that may wish to be coming into Plymouth, autonomous vessels. And we chose a 150-meter ferry, fully calibrated. It's part of the extensive Rembrandt ship model database, which has been developed over 30 years. So fully calibrated hydrodynamically for maneuvering and sea keeping. So that was ready-made to come in. Utilized the autonomy autopilot feature within Rembrandt as well. And we did a series of runs which were performed on the Smeaton Pass area in Plymouth Sound. Some commercial recreational traffic was in the vicinity, but it didn't really interact with the ship's own passage. The stronger predicted period of flood tidal flow was chosen for the exercise, and a nominal 50-knot southwesterly wind as well. Maximum tidal current experience was around about 1.5 knots, similar to that for a spring tide cycle in the area. And again, just a bit more detail on the ferry. It was just under 150 meters, 4.4 meter draft, twin screw Ro-Ro ferry. And, happy to, if there's any other questions at the end of this on the sort of model we've chosen and why, then happy to join. I'm also joined by Don Cockrell, who is an ex-pilot and formerly chairman of the UK Marine Pilots Association, who assisted us very, very well in overseeing the actual simulations itself. And Don's there, so he's able to also answer any questions at the end of this. You'll see there just a view on the bottom of the S102 with the water removed of Plymouth as well. Trial results, I'll just canter through this really. We've done several runs, one with and without the autonomous autopilot. Don, I don't know if you want to unmute and perhaps say a few words on this if you're able to.
Yeah, good morning. Well, what have you got in mind, Phil, as to the process we went through, or just the just looking at it?
Maybe a summary of the results, I think, or anything else. Anything that came out which were interesting from a pilot's point of view.
I think the thing that came out of it more than anything else was just the whole genuine feasibility of it. The data was there, the data was available to be input into the process, it's not so much a case of the autonomous ship would do it any better than doing it from a manned pilotage point of view, but it's certainly under those closely monitored circumstances, it was certainly the equivalent of being able to take it around safely under those particular circumstances. Under different meteorological conditions, you might need to look at it a slightly different way, but under those fairly standard, relatively benign conditions, then it's certainly a successful and feasible trial. As can be seen from the tracks, we didn't need to. Interestingly, it became very apparent very early on that it was a perfectly viable and successful trial in itself. We didn't need to sort of do things multiple times to prove something. But I'll say if anybody's got any questions, I'm quite happy to answer them on that.
Thanks, Don. Thank you. So this is just, there's nothing particularly very interesting, as ship navigation generally is, like watching paint dry at times. But here's a 2D Rembrandt overview and a 3D bridge view while we're doing the autonomous navigation. Again, you'll see one or two vessels in the vicinity, but there was no need to interact with them on this particular instance. The following slides here basically just show you, I mentioned about underkeel clearance. Here is the vessel with the water removed, and the level of granularity because of S102 bathymetry and the dynamic water height data really does allow, a whole new dimension about dynamic underkeel clearance, really, in terms of ultra high granularity data exploitation. Just to finish off with, part of the challenge was also to identify how we would take our ideas and our fused products and the fused S100 level of data forward into existing and new markets. And what was quite apparent is the markets clearly on autonomy are very exciting, but frankly, what we've developed has immediate applications to manned shipping as well. So we've just summarized here 8 potential markets, and we're actually actively with the UK driving forward on 3 aspects of these now, just in terms of making sure we get where we think the short-term opportunities are absolutely right. The first one shown there is, in terms of ports becoming more digitally enabled and perhaps autonomy enabled. But in terms of actually accessing data of much higher granularity than what's present. In fact, many ports might have data which is quite granular, but they don't know what to do with it. Well, what we've developed now with the UKHO is a platform to actually use any granular data, be it through the UKHO or using their own data, to develop ultra-high granular dynamic port digital models. So that would help address not just things like under clearance, but also, dredging strategies going forward. Do we need to dredge, or where do we best target dredging, or, what extra vessels and how bigger vessels can we actually get in without necessarily having to dredge? And also what more traffic can we get in, perhaps, to look at port utilization. So that's clearly one area. And it will also, of course, in the longer term, by adopting more granular and dynamic digital models, also enable ports to prepare for autonomy as well. That's a very exciting area, and we're already working with quite some early success with the UKHO on that particular area. The other one next to it, again, is underhue clearance. I've mentioned really why we think the technology that's been developed with the UKHO data and with the fused Rembrandt two-flow offering allows for quite a unique approach to new dynamic underhue clearance, ultra-high granularity underhue clearance modeling. Of course, one thing about moving into autonomous navigation is there's going to be a huge need to train, from pilots to ports to also manned shipping on how to deal and interact with autonomous vessels. Because what we've done over several years in Innovate UK projects and working with autonomous vessel manufacturers is the key risks actually are not necessarily in a fully autonomous world. It's actually in this awkward transition period of the next 15 to 20 years where you've got increased amounts of part autonomous, fully autonomous traffic interacting with manned vessels. And those decisions on the human factors, the uncertainty when you've got this interaction between manned and unmanned traffic is potentially a risk, certainly to navigation. And so there's going to be a lot of demand and requirements, I think, to train not just autonomous operators and pilots and ports, but also manned vessel operators on how to deal with that. There's also opportunities to feed into autonomous vessel design support. BMT has a number of designs of autonomous vessels, and this sort of data would also support the design of autonomous vessels. An interesting area, because Rembrandt's fitted on many ships worldwide, mostly LNG and cruise, think of high operational and safety risk vessels. Having more granular data anyway, such as the UKHO data with onboard decision-making they're using right now with Rembrandt, allows for actually the potentially much improved decision-making and training particularly on board, because they will then have access to ultra-high granular data in real time. So there's a huge market there, I think, even for manned vessels now to adopt this type of technology. Autonomous systems insurance is clearly an area that I think the market has to embrace. It raises all sorts of questions in terms of cybersecurity, COREG compliance, loss of GNSS, and how one navigates an autonomous vessel, or how an autonomous vessel behaves with loss of GNSS data. That's a huge area, which of course this kind of approach could support. BMT is also the world's leading search and rescue software provider. We support most of Europe, for example, in search and rescue planning in terms of drift modeling. And there's a lot of interest right now in moving towards more autonomous SAR assets, both in terms of drone technology, but also floating SAR assets as well. So Of course, there's an area that BMT is actively exploring right now, using some of the technology we've done in the UK Innovation Challenge to actually translate that across into SAR planning and SAR operations as well. And I mentioned earlier, because Rembrandt's used by most of the world's leading statutory marine investigation bodies, so in the UK, as well as the US, NTSB, the counterparts in Australia, the Netherlands and Singapore have also used this for actually accident reconstruction. The one thing that will always be needed, I think, with autonomy going forward is to look at designs, but also in operations, and to actually stress test the behavior of decision-making algorithms by seeing how they behave in very stressful, high risk of collision and grounding environments. And we have the tools there with UKHO data to actually start rather just manned vessels looking at accidents, but actually looking at all sorts of scenarios going forward now to look at digital forensics in autonomy. So those just give you an idea of the sort of 8 markets that BMT and UKHO will be working together going forwards. And some of them are prioritized, some of them are actually getting very early traction already in that, and others are perhaps more the 1 to 2 time horizon. Happy to take any questions on any aspects, but thank you.
Brilliant. Thank you very much, Phil. I have had a couple of questions come in to me privately, but people, if you keep submitting your questions, that'd be great. So the first one is, are you integrating as-built ship digital twins into Rembrandt? And if so, will this include onboard IoT datasets?
Right, just trying to understand the question. We have, we continually work with autonomous ship operators and also manned vessels, and we're in a continual perpetual state of developing new fully calibrated hydrodynamic models, be it ferries, small autonomous vessels, super yachts, offshore rigs, cruise ships. So as part of a digital twin within navigation, we are continually expanding our large hydrodynamically calibrated database. What we do is we develop a hydrodynamic ship model, a digital ship model, based on either a pilot card from a vessel or ship trials. And we also actually tend to refine that by bringing in masters or pilots who've got explicit experience of actually manning those types of vessels to make sure it feels like that vessel. So we have 3 levels of calibration before we put it into our calibrated hydrodynamic database. So the answer is we're just perpetually developing new models. It's part of what we do. And of course, as I said earlier, part of the digital twin is that we created a 2-floor a coastal hydraulic model of Plymouth in less than 48 hours. So it's not a huge task for us to actually come across a new port, a new vessel, and create those very quickly into what are, fully digital twin, part of the wider digital twin for a port or a ship.
Brilliant, thank you. Matthew, I don't know if you had anything to add to that.
No, that was fine. Thank you very much.
Brilliant, thank you. So then the next question is, to what extent can the models be used in ports where the necessary data is difficult to obtain or might not be available? Or in other words, what's the minimum level or standard of data that needs to be available for the model to be successful for autonomous applications?
Mark in his earlier presentation did allude to the fact that the S57 is inherently limited in terms of ENCs, in terms of on an ENC quite now with an S57, you have typically 5 or more often 10 meter intervals of contours. Now the problem becomes in a ship, and we've undertaken a similar S102 simulation in Southampton. We have a lot of data equivalent to S102 for Southampton, and we've actually looked at container ships coming in there. And if you're looking using existing S57 data, you actually avoid areas. Say, for example, if you're in 11 meter depth, then actually that would be blanked out because it moves them to 15 meters. And if you're starting to have S102 level of granularity, you can actually take things down to literally 1 meter gridded bathymetry data, which allows more scope for safe maneuvering and safe navigation. What becomes useful, I think, well, the UKHO, of course, are at the forefront of developing very granular data and converting that to S102. So it may be that a port that wants to exploit this type of technology, the UKHO may well have the data there that is either somewhere between S57 and S102 or 102, and it needs to be utilized on our platform. But actually, a lot of ports actually have their own data anyway, but don't know what to do with it. It's not an ENC that ships use coming into that port, but they've perhaps got some good bathymetric data that they've surveyed. Well, that data could just be fed straight into our models now, so they're fully using whatever data they've got as well, in conjunction with any UKHO data that may be available. So it'll depend on each port, but a lot of ports are sitting on a lot of data themselves, but they don't know what to do with it.
Brilliant, thank you. Han, are you happy with that, or did you?
Yeah, that's fine. Thank you very much.
Brilliant, thank you. And then I guess just a question from me, the same question I asked Mark, really. How did you find, in terms of the actual challenge, how did you find doing it remotely? Was it easy to get into the challenge and do the work that way?
When we found we got through to the final, it was a bit of a loud collective gulp from my team. We were going to do this in a week, and because of the commitment from our fantastic team in Australia and the UK, working day and night, and really doing it very smartly and cleverly as well. I think the overriding impression was we had a lot of fun and we really enjoyed it. Hopefully I'm not putting words in my team's mouth. I think at the end of the day it was, and because we've identified a number of exciting markets for early exploitation, that's the icing on the cake for us. But even without that, it was a lot of fun, and we actually really enjoyed ourselves. And we actually we had quite a clear vision on day one, what we wanted to do. So Mark said, often people have a kind of a vague sort of idea, and often you do. But actually, we had really clarity of what we wanted to do by that Friday and how we were going to do it. I have to confess that really helped us.
Yeah, brilliant. That sounds good. And I've had one more question come in. So for this data to be used for navigation, how regularly would the hydrographic data need to be updated?
Right. Mark, if you're on mute, do you have any views on that? I mean, I've got my own views, but in terms of UKHO data.
Hi, I don't know if people can hear me and see me.
Yeah.
I mean, clearly we have an update regime now, which is weekly for ENCs, and obviously we publish NMs and all the rest of it. One of the things that the UKHO is looking to do is go to a more kind of real-time updating regime in kind of at the same time scale as we transition to the new S100 standards. And, I think if you think long term, an autonomous vessel will need to always be on and always listening, wanting to receive, these dynamic updates. So I think, today it's weekly. I think the future, it's going to be as and when data changes, because the systems will need to be aware of changes as and when they happen. And update it's kind of, it's onboard real world model as and when new changes are made available.
Just to add to Mark's comments, Emma, because we're using predictive tools, and particularly our coastal hydraulics model is a predictive tool into the future as well. So we've got that ability to forecast, but also hydraulic model can forecast sediment transport issues. So if in certain areas of the world we're not getting, there's perhaps a lack of regular updates in some ports or some areas, then the coastal hydraulics model can actually look a bit ahead of itself about what it's likely to, in terms of silting up in the next 6 months. Is that going to have an impact? So the idea of having this synthetic model, which is inherently predictive as well, would also help to mitigate that. But as Mark said, it looks as though the UKHO are, stepping up in terms of the regularity of updates now.
Brilliant. And I think Gordon's just sent a kind of a follow-on question. So how insignificant is the impact of using historical data between surveys without any modelling for rate of change?
I think
Is that insignificant or significant?
Well, it says insignificant, but Gordon, I don't know if you want to unmute yourself but yeah, maybe, yeah, significant. How significant is it?
I mean, from my own perspective, I'm not sure I have the answer there. I mean, clearly the new standards, the S100 standards, and particularly for bathymetry, doesn't really allow for that kind of temporal modelling. It doesn't allow forecast or hindcast or anything like that. But, you know, I think the interesting space we're in here with autonomous vessels is, you know, all better off. Really, there should be new data services that, as I say, are needed by autonomous vessels, and that's what we're trying to, I guess, elicit from the industry. Is what do you need, kind of going forward? You know, don't constrain your thinking to charts as they are today. Don't constrain your thinking to the new S100 standards. I think the S100 standards probably solve 80% of the kind of challenges I described in my presentation, but I think there's a whole host of new data services which you know, potentially the type of thing that Gordon's alluding to could be very, very useful for autonomous vessels. So I think for me, all better off, and I'd like to see the industry really kind of exploring what it does need, because quite often when I engage with industry, there's almost an element of not sure or don't know what they don't know, if that makes sense. So there's an acceptance of what there is today and the kind of make do, but actually the industry should be driving what the new standards are for the future. I don't know if that's helped, Gordon. I've tried.
No, I'd just finally add that being EAS enabled and EO, Earth observation data enabled, you know, we have scope to expand well above what we've used there. But also we've deliberately in our challenge, our system actually takes dynamic data coming in and can be as temporal granular, i.e., you know, if we wanted a minute's granularity of data rather than 10-minute time granularity, it's doable. Once you develop those models, you can actually then force it to deliver what you need appropriate to the task, be it autonomous or manned.
Brilliant. Okay, thank you. And Gordon's confirmed that he's happy with that, so you've answered that well. So thank you. That's it on the questions for now. So I think what we'll do is we'll move on to Rob, and then if anyone has any more questions, we can come back to them at the end. So do carry on putting them into the chat. So thank you, Phil. I'm just going to share my screen for Rob. Rob, let me know if you can see it.
Yeah, it's come up, Emma, thanks. Can everybody hear me?
Yeah, we can.
Okay, brilliant. Okay, well, thanks, Emma, and morning, everyone. I'm Rob Watson. I'm the Director for the Marine Business Technology Centre in Plymouth, and I'm going to be talking about Smart Sound Plymouth, our testing and proving ground based in and around Plymouth Sound. So, Emma, do you want to move on to the next slide for me, please? Okay, if we let that build. Okay, so I think before we get into Smart Sound, it's probably worth just touching on the Marine Business Technology Centre and what we do. So we are a European Regional Development Fund-backed innovation service that's specifically looking at supporting next generation technology development in advanced marine. We've been running since mid-2018, and we're due to run until August of this year. And during our time, we've actually engaged over 300 businesses and helped develop a number of significant new technology areas. What's come to the fore, and part of this has been touched on by both Mark and Phil, is a number of focus areas that Plymouth is leading on. Top of that list is applied autonomy. There's a number of projects that you may have seen that we're engaged in. One is around the autonomous mine detection and removal that Thales are building at Turnchapel Wharf. We're also quite heavily involved in the Mayflower autonomous ship project, which again has got quite a lot of coverage. This is a scientific platform that was looking to replicate the voyage of the Mayflower across the Atlantic last year for the 400th anniversary. Clearly with COVID, that's been postponed, but it's looking to operate again this year. So hopefully this year that will take place. What's also increasingly becoming important to us is the whole area of alternative propulsion. So we have a number of projects underway. One is the eVoyager, which is a fully electric passenger vessel that's operating in Plymouth. That's being tested at the moment and is utilising Smart Sound Plymouth to do that testing and certification. We also have a number of projects that are looking at hydrogen, and recently we've picked up another project which is to convert a large classic passenger vessel, a 1930s passenger vessel in the River Dart, to electric power. So increasingly this is becoming important. The project, the MBTC project, is led by Plymouth City Council, but the key sort of horsepower behind this are the research partners that we have. So that's Plymouth Marine Laboratory, Marine Biological Association, and the Universities of Plymouth and Exeter. And as you would expect from those partners, we've got a very strong focus on environmental monitoring and measurement, air quality, water quality, etc. So that's kind of fundamental to what we're doing as well. And underpinning all of this is the whole area of cybersecurity, big data, Internet of Things, not just in the autonomy space, but across the board really. So it's all about gathering that data and using it intelligently. The MBTC is also the administrator for Smart Sound Plymouth, and what I mean by that is that any testing and trial operations that happen in Plymouth Sound and Smart Sound as a test area are run by us. So effectively the idea is that we make sure that it's very easy for particularly SMEs to come down to a fully instrumented and managed environment to conduct real-world testing of technology. Smart Sound itself has been around for quite some time, and actually prior to the MBTC coming into existence. But its original focus was very much around science and scientific monitoring. Central to it is the Western Channel Observatory, which is run by Plymouth Marine Laboratory. As most of you will probably know, this is a meteorological and environmental buoy array. It provides data into the Met Office. It provides scientific data for water quality, etc. So that's those data buoys were already there. Other equipment also from the partners was available, but as I say, it was very much based on scientific observation. So when the MBTC came into being, what we actually looked at was whether this could be commercialized or the assets could be used in a different way. So what we've actually done is we've added to the equipment that was already in place. So we are in the process of updating one of the data buoys for the Western Channel Observatory. There's some more detail on that in a bit. We've acquired our own unmanned surface vessel, a Seaworker 4, named USV Cetus, which is run by the University of Plymouth. And we're also looking at investing in EcoSub Robotics, a subsea data nodes that are able to provide yet more data that can be rolled into this. The final piece of equipment is the acquisition of an Autonaut 5 meter. This is for long-term autonomous testing, particularly out in harsher conditions. Where Smart Sound is unique, we feel, is it's not just because of the instrumentation and management that we have there, it's the mix of conditions. So if people are familiar with Plymouth, it actually gets quite deep quite quickly, and certainly at the outer reaches of the Smart Sound area, which is approximately 20 to 25 miles offshore, you get proper weather out there, both tide and wind and waves and so on. So as a real world testing environment, it covers pretty much all of the range of conditions that you would wish. And obviously with that deep water, we can start to do subsea type activities as well. The total coverage for the range is 1,000 square kilometres. And as I say, it's fully managed by us. So all the deconfliction and so on that will be required for businesses to test in the area is done by us. And the key element here is that it's free of charge. So if people want to come down and use it, it's a question of contacting us, and we can help you plan your trials and testing in this environment. Emma, can we move on to the next slide, please? So I mentioned the updated buoy. The buoy that we are updating is L4. Now this is the inshore buoy. This is a state-of-the-art data buoy that's able to provide live data. So rather than doing it in packages, it's constantly connected. So that allows real-world environmental monitoring. It also allows businesses that want to test to plug into the buoy itself, to utilize it as a communication node, or to utilize the data that it's monitoring anyway. So as I say, this is primarily meteorological, but it is able to look at other elements as well. So very, very strong platform. It's probably not apparent on that picture how big it is, but where you can see the door open there, effectively you can get 4 people in there. So it's not a small thing. It also has subsea monitoring capabilities as well. So we're starting to spec out some testing programs for businesses that want to look at subsea sensor testing. That's a very good use case for it. And as I say, it can act as a communication mode for autonomous type vessels as well. So very, very high tech. It's probably one of the most complex market leading buoy platform in the world. We think there's only one other that's been deployed internationally. So for the UK, this is potentially a fantastic asset. Emma, do you want to move on? So we'll let this build. So Autonaut are a local business to us. I'm sure there are people on the call that are fully aware of what Autonaut do. This is a 5-meter fully autonomous platform. It's solar and tidal powered. So it's completely self-contained. And what generally people are using this platform for is long-term testing. So there's a number of use cases that have come up. One of the things that we're looking at to augment Smart Sound Connect, which I'll get onto in a second, is whether this platform could be used for as a 5G node, for example, to push communications out. The other logical area for working, which again we're starting to get quite a lot of interest in, is the whole area of monitoring for fisheries, border control, and offshore renewable platform maintenance and surveying. So this platform is very powerful. It's able to do a lot of different activities, and again, it's there to be used by businesses free of charge. So if there are programs that people feel fit this particular platform, we'd be more than happy to talk to you. Emma, can we move on to the next, please? Mentioned the Eco Sub fleet. These are connected subsea autonomous vessels. They're able to swarm. They're able to talk to each other. Again, feeding into the communication system that we have in place already for Smart Sound Plymouth. And really what they're there to do is to assist businesses that want to look at subsea type activities. So Phil and Mark have already mentioned a couple of things where this would be relevant to. We are working with them for subsea or seabed mapping. They've done a number of projects already with this, and clearly they have the ability to provide that data live to port operators if need be, and it allows modelling, as I think Phil mentioned, around dredging, the need for dredging, and what the current environment on the seabed is and how that potentially affects shipping. So that's one particular use case we're working on, but there are many others, and similar to the Autonaut, they can carry various sensor arrays. So if businesses are looking at subsea type operations, then these platforms will be available from about April of this year. Emma, can we move on? Okay, so just a couple of augmented elements that Smart Sound has recently acquired. So in the middle of last year, we secured some funding from Heart of the Southwest, LEP, to create the world's first ocean-based 5G network. Now, what this is being implemented as we speak, but the idea is to create some areas of coverage that are 5G to allow operations to take place. Now, they will primarily be in the areas that we've already touched on. So applied autonomy clearly has a use case here. But also there's the whole area of air quality, situational awareness, et cetera, et cetera. So the whole idea is to provide a free of charge, high-speed data network that businesses can come down and utilize to test the next generation of technology that they're developing. This is augmented by a high-speed data mesh network, which ensures that we've got full data coverage across the extent of Smart Sound itself. So it covers the full 1,000 square kilometers. And again, from a testing point of view, that means that we've got guaranteed high-speed live data coverage. Can we move on to the next? Okay, another project that we're working on, which obviously mirrors to a certain extent what BMT are doing, is Smart Sound Digital. The logical extension to this, if we have the data network and we have the data assets, is to create a virtualized testing and proving ground, again, for business to come down and use. The principle behind Smart Sound and MBTC is it's about providing these facilities as cheaply as possible, free of charge if we can. But the main point is that all of the management, all of the support and so on is done by our team. So particularly for SMEs, this is quite powerful. The other element that we're looking at here is creating this as a live virtualized testing environment. And the reason for that is it provides the ability to very quickly and easily test new products and technology in an environment that is directly tapped into what is happening at that time. So depending on the weather conditions and so on, we can look to potentially test and prove technology quickly, virtually, before it's actually rolled out into the live environment. Where this is also important, and we're increasingly getting involved with, is the whole area of certification and testing. That's ultimately what this platform could be used for, in alignment with the Smart Sound Live testing range. So again, it's building on the strengths that we have. It's looking at the technology areas that we're leading on, and we're looking to put together the best possible package we can to allow businesses to come down and use and test in the environment. Emma, can we move on to the next one, please? We've also managed to establish a very strong cluster in Plymouth and the surrounding area. This is called the FAST cluster. So that's a Future Autonomy at Sea technology cluster. And it's now numbering around 35 businesses and other organizations. So the key here is that it is actually triple helix, and what we mean by that is that you've got the combination of local government, central government, industry, and academia. And this group are actively working together on projects. They actively support each other. We've done promotion as a group. And where it really helps with the development of technology is that if businesses come in and engage with Smart Sound Plymouth, a lot of these businesses are either working in the area, utilizing Smart Sound, or they are providing equipment and services and data and support into it. So there's actually an opportunity for businesses to come in and collaborate with not only us, but the businesses that are named in this group, as well as the research organizations. We are looking to produce a film, and we've done one already for Maritime UK Southwest. That's on the slide here. I think it's probably better, given the time constraints, maybe to share it as part of the presentation. But we are working with ITN, and we are looking at another Associated Press production over the next few months to actually promote what we're doing and promote the businesses that we're working with. So there's potentially an opportunity there if businesses are interested in getting involved to be part of that. Can we move on, Emma? So a couple of other elements with regard to central government. We have submitted an application which has been accepted to the Department for Transport for Plymouth to be designated an innovation hub for advanced autonomy, marine technology and digitalisation. That has been approved, but we're just waiting for the final announcement. Can we move on to the next, Emma? With regard to DIT, Maritime UK Southwest, which we fall under, has been identified as a high potential opportunity in advanced autonomy, marine technology and digitalisation. What this means is that DIT are actively supporting the activities that we're looking to do and helping us to build those international links. And interestingly, we have established a number of those already with similar testing and proving programs in Canada, Norway, Singapore, Germany, and various other places. So that's starting to develop quite well, and probably represents another opportunity for organisations to get involved with us. And the next one, Emma. And finally, one of the things that we've looked at from a Southwest perspective is how we can actually look to pull together all of the various elements that are going on. Obviously, we've established a very strong program in Plymouth, but it's not just Plymouth that's involved in this. So we are working with the likes of Dorset, Cornwall, and City of Bristol, Wilbraham, etc., to pull together a proper positioning statement and proper project plan to develop the overall offer for marine innovation in the Southwest. This is nominally called the Future Ocean Institute. It's been presented to the three departments there, and totals around £250 million worth of investment. So what we're looking to do here is to make sure that the investment is that comes from government is invested in the right place, covers the right things, and plugs into the national agenda for marine and maritime. And I think, given that we've got about 3 minutes left, Emma, that's it from me. So I'm happy to take any questions.
Brilliant, thank you very much. Let me just stop sharing my screen. Brilliant. So I haven't had any questions coming in through the chat. I'm not sure if anybody has any questions, but I mean, I think it sounds fantastic. It's a fantastic asset for the marine science and technology and maritime sectors in the UK, really, like you said. And I think if any companies are interested, SMI members or not, are interested in utilising the Smart Sound, then let me know, and I'll happily introduce you to Rob. Unless there's any last minute questions, which I'm not seeing, then I think it just leaves me to say thank you very much to everyone for attending today. Thank you very much for our 3 speakers for your fantastic presentations. If anyone has any follow-up questions, then feel free to send them over to me, and I can send them over to the speakers and get responses to you. So yes, thank you very much, everybody. Take care, and hopefully we'll see you all soon.